Welcome everyone to the TCE online MOOC course on predictive analytics. I am Dr. T. Shiva, working as an assistant professor in Department of Computer Science and Business Systems in Thiaraja College of Engineering, Madurai. In this lecture, we are going to learn about an important and widely used machine learning technique called decision tree. The title of today's lecture is Introduction to Decision Trees. Decision trees are one of the easiest machine learning algorithms to understand because they represent decisions in structure that look very similar to the way human beings make decisions. For example, when we decide whether to approve a loan, we may ask questions such as: is the person's income high enough? Is the credit score good? Does the person already have a loan? Based on these questions answer, we finally arrive at a decision such as approve or reject. This is exactly the base idea behind the decision tree. By the end of this lecture, you should be able to understand what a decision tree is, why it is useful, its major components, and how it's working using recursive partitioning. Let's first understand where today's topic fits into the overall course. Currently we are in Module 8, which focuses on decision tree and related techniques. The module contains several topics such as Introduction to Decision Tree, which is today's topic. Then we will move on to decision tree terminologies and tree construction. After that we will study the decision tree building process. We will then discuss about the model validation and pruning technique. Following this, we have chi-score automatic interaction decision. We also study classification and regression tree, random forest and ensemble learning, decision tree case study and practical implementation. Finally, we will look into decision tree case study and practical implementation. So, today's lecture provides the foundation for the remaining topics in this module. If you understand the basic structure and working principle of decision tree clearly, the later topics such as cat, random forest becomes much easier to understand. Let's begin with the overall concept. The broad area we are studying is predictive analytics. Predictive analytics is closely connected with the machine learning. One of the machine learning techniques used for predictive analytics is decision tree. The basic flow can be understood as historic data, predictive analytics, decision tree model, prediction and business decision. Let us understand this flow. First, we collect historic data. The data contains information about previous events or previous customers' transaction, patient's application, and so on. Next, we use predictive analytics technique to identify patterns in the historic data. A decision tree can then be developed using this data. Once the decision tree has learned the patterns, it can be used for making predictions for new data. Finally, those predictions can support business decision. For example, if a bank wants to decide whether to approve a loan, historic customer information can be used to develop a decision tree. The model can then predict whether the new applicant is likely to be approved or rejected. So the decision tree acts as a bridge between historical information and future decision. So this is the course outcome we are focusing on in this module. Construction decision tree to improve predictive capabilities using pruning and ensemble model. These are two important ideas here. The first is constructing a decision tree. We should know how a tree is developed from the dataset. The second is improving the predictive capability using the techniques such as pruning and ensemble method. The pruning helps us control the complexity of decision tree. Ensemble method combines the multiple models to improve predictive performance. We will study these concepts in greater detail in the upcoming section in this module. For today's lecture, our focus is primarily on to understand the foundation, what decision tree are, why we use them, their structure and how they work. Why predictive analytics? Now let us ask the important question, why predictive analytics? Modern organizations generate enormous volume of data every day. Think about a bank, hospital, e-commerce companies, telecommunication companies, manufacturing industry, and educational institutions. Every transaction, every customer interaction, every purchase, every payment, and every service request can generate data. But simply storing this data is not enough. An organization needs to analyze these data and extract useful and actionable information. For example, imagine a Imagine that a bank has several years of customer loan information. The bank may have information about customer income, credit score, employment status, existing loans, payment history, and previous loan approval decision. If the bank simply stores the information, it's just a historical data. But if we analyze this information, we may discover patterns. For example, we may observe that the customer with particular combination of income and credit score are more likely to receive the loan approval. So the predictive analytics helps us use these historical patterns to estimate future outcomes. This is like key idea. Predictive analytics uses historical data, statistical techniques, and machine learning algorithms to estimate what is likely to happen in the future. So instead of just asking what happened, we move towards asking what is likely to happen next. This change in perspective is very important. Traditional reporting mainly tells us what has already happened. Predictive analytics helps us make informed predictions about future outcomes. What is predictive analytics? Let us formally define predictive analytics. Predictive analytics is a branch of data analytics that focus on predicting future outcomes using historical data. These are the two important words here, historical data and future outcomes. Historical data provides the evidence. Predictive analytics use that evidence to estimate a future outcome. Let us take a simple example. Suppose a telecommunication company has historical data about customers. The company may know how much customer pays, their contract type, their internet usage, how many times they contacted customer support, and whether they eventually left the service. Now, when the new customer comes into the system, the company can use the historical pattern to predict whether that customer is likely to leave. That is the predictive analytics. Similarly, in healthcare, historical patient information can help predict whether the patient belongs to a particular risk category. In banking, historical customer information can help predict loan approval. In manufacturing, historical machine information can support predictive maintenance. So, predictive analytics has application across many industries. Machine learning. Now let us connect predictive analytics with machine learning. Machine learning enables computer to learn automatically from the historical data without being explicitly programmed for every individual decision. This is an important difference. In traditional software, a program explicitly writes the rules. For example, we might write if income is greater than certain value, approve the loan. If the income below certain value, reject the loan. These rules are manually created. In machine learning, instead of manually writing every rule, we provide historical examples to the machine learning algorithms. The algorithm analyzes this data and discover useful patterns. These discovered patterns are then represented by models. The model can be used to make predictions for new data. This is why machine learning is useful when a decision making rule are not always obvious or not too complex to write manually. Decision trees are one of the machine learning techniques that can automatically learn decision rules from historical data. The types of machine learning. Machine learning can broadly be classified into three categories shown in the slide. One is supervised learning, then unsupervised learning, and reinforcement learning. So let us briefly understand each one. Supervised learning is a learning which uses labeled data. That means the input data is accompanied by the correct output or target. Example, decision tree, linear regression, random forest, and support vector machine. The applications include decision prediction, disease prediction, loan approval, and email spam detection. For example, if we have customer information alone with the actual loan approval decision, the data is labeled. The model can learn from these examples. The second category is unsupervised learning. Here we use unlabeled data. The algorithm tries to discover the hidden structure or group in the data. Example, k-means clustering and hierarchical clustering. Applications include customer segmentation and market-based analysis. For example, an organization may have customer data but may not have the customer groups in advance. An unsupervised learning algorithm can identify the groups of similar customers. Then reinforcement learning. The third category is reinforcement learning. Here, the system learns through interaction with the environment. The application source in this slide includes robotics, game playing, autonomous vehicles. The important point to remember is decision tree belong to supervised learning. That is because a decision tree learns from the historical example where the correct input is already known. Next, understanding supervised learning. Now let's focus on specifically on supervised learning. Predictive analytics helps us use these historical patterns. Supervised learning trains a model using historical examples where the correct answers are already known. Consider a simple loan approval example. Our input variable may include age and income. Our target variable is whether a loan is approved or not. Suppose we have many historical records. Each record contains customer's age, income, and final loan approval decision. For example, one customer may have a particular age and income, and the corresponding result may be approved. Other customer may have different values, and the result may be rejected. The algorithm examines these historical examples and tries to learn the relationship between the input variable and the target variable. After training, when a new customer applies for a loan, the model can use the customer's input information to predict the target. This is basic supervised learning process. Decision trees are particularly interesting because the learned decision process can be represented in the form that humans can easily follow. Decision tree. Now we come to the central concept of today's lecture. What is decision tree? The decision tree is supervised machine learning algorithm that represents decision using a tree-like hierarchical structure. There are three input components that we should remember. First, each internal node represents a decision. Second, each branch represents an outcome. Third, each leaf node represents a final prediction. Let us understand this using an example shown in the slide. The first question might be income greater than 50,000. Based on the answer, we move along one of the branches. Then another question may be credit score greater than 700. Finally, we reach the results such as approve or reject. This looks similar to flowchart. The important difference is that the decision tree is learned from historical data. So instead of programmer manually designing each and every question, the machine learning algorithm identifies the useful splitting conditions from the training data. This makes decision tree explainable. If someone asks why was the application rejected, we can follow the path through the tree and see the condition that leads to the final decision. Next, root node. Let us now study the terminology used in the decision tree. The first term is root node. The root node is the first and topmost node in the decision tree. It represents the entire data set. The first condition used to divide the data set is selected at this point. There are several characteristics of a root node. First, it appears only once in the tree. Second, it represents all the training samples. Third, it has no income branches because the starting point. Fourth, it produces child nodes. The most importantly, the root node is selected using best splitting criteria. The later topic we will discuss about different criteria used for selecting the best split. For now, remember this is a simple definition. Root node is starting point of a decision tree. Next, decision nodes. Decision nodes are internal nodes where the data is further divided based on another condition. A decision node asks a question about one of the feature. For example, is the credit score greater than 700 or is the employment status is permanent? The answer determines which branch we follow next. A decision node generally has one incoming branch and two or more outgoing branches. The process continues until eventually we reach the leaf node. So remember, the root node starts the process, decision tree continues the decision making process, leaf node provides the final prediction. The next terminology is branches. A branch represents the outcome of a decision tree. It connects a node to another. For example, the question is income greater than 50,000. If there may be two outcomes, yes or no. Each outcome can follow a branch leading to another node. Branches are important because they represent the possible decision path. Different branches can eventually lead to different predictions. When using decision tree, we can think of process as following a path. We start at root node, we answer question, we follow the corresponding branch, we reach another decision node, we answer the question, we will continue until we reach the leaf node. The leaf node gives the final prediction. How does a decision tree work? Now let us understand how a decision tree actually works. Decision tree use a process called recursive partitioning. This is very important term. Let us understand it in simple way. Suppose we start with one large data set containing many customer records. The algorithm selects suitable feature and divides the data set into smaller subsets. For example, it may divide the customer based on income. Now we have smaller groups. The algorithm then examines each group and may divide them again based on another feature, such as credit score. The process continues repeatedly. Therefore, the original data is gradually partitioned into small and smaller subset. That is why we call it as recursive partitioning. The process continues until the subset becomes sufficiently pure and another stopping condition is reached. The word recursive means that the same process is repeatedly applied to the resulting subset. So overall process can be visualized as large data set, first split, small subset, future splitting, smaller and more homogeneous subset, final prediction. The ultimate objective is to create using group that allows us to make the accurate prediction. This is an example of a loan approval process. Suppose a bank has a historical customer data. The input variable includes annual income, credit score, existing loan, and employment status. The target variable is loan approval. Now imagine that we want to predict the loan approval decision for a new customer. A decision tree can examine the customer's input information. For example, the first question could be based on annual income. Depending on the result, the tree may ask another question about credit score. Then it may consider whether the customer already has existing loan. Finally, the employment status may also be considered. The process of eventually reaching the leaf node that gives the predicted decision. This is very simple example, but the same basic concept can be applied to much larger datasets. The major advantage is that the decision process can be visualized. Instead of seeing the predictions as a mysterious output, we can follow the path of decision. This is one of the important reasons decision tree is widely used. Application. Now let us see a healthcare application. Suppose a healthcare organization has a historical patient information. The model can learn patterns from the available data and use those patterns to support prediction. For example, a healthcare application may classify patients into different categories based on available patient characteristics. The important advantage highlighted in our context is ability to represent decision in an understandable structure. A doctor or a healthcare professional can follow the decision path and understand how a prediction was reached. This property is commonly referred to as explainability. However, it is important to remember that the machine learning model is a decision support tool. It does not eliminate the need for professional judgment. Another application area shown in this presentation is logistics. Logistics organizations generate large amount of operational data. Decision tree can be used to identify the patterns and support predictive decision. For example, based on the historical information, a model can classify or predict the outcome associated with the logistics operation. The general process remains the same. We start with historic data, we identify the input variables, we train the decision tree, the tree learns decision patterns, then the trained model can be used to make predictions for new cases. Therefore, the decision tree approach is not limited to banking. It has applied across different domains, whether it's suitable to be labeled is available. Now, based on this lecture, let us have a small quiz just to know the understanding of the concept. First question is, which industry primarily uses decision tree for predictive maintenance? Option A, banking. Option B, manufacturing. Option C, healthcare. And option D, retail. Please pause for a moment and think about the answer. The correct answer is option B, manufacturing. Predictive maintenance is associated with identifying potential equipment or machine related outcomes using historical operational data. So manufacturing is appropriate answer here. Second question. Why are decision tree widely adopted in healthcare? The options are: they require GPU hardware, they provide explainable decisions, they only work on images, they estimate the need for doctors. The correct answer is they provide explainable decisions. One of the important strengths of decision tree is the tree is like it is like a tree structure. We can follow the decision path and understand the condition that resulted in a particular prediction. Option A is incorrect because repairing GPU hardware is not the reason for using the decision tree. Option D is incorrect because decision tree are not limited to images. And option D is also incorrect because machine learning models do not eliminate the need for doctors. So remember, explainability is an important advantage of decision tree. Next question is, which machine learning algorithm is most suitable in doc if a doctor wants to understand why the patient is classified as high risk? The options are K-means clustering, B. decision tree, C. artificial neural networks, D. principal component analysis or PCA. The correct answer is decision tree. Why? Because the decision tree represents the prediction through sequence of understandable decisions. We follow the path from the root node through decision nodes and the branches until we reach the final leaf. K-means is primarily used for clustering and PCA is mainly used for dimensionally reducing. Therefore, among the options given, decision tree is most suitable algorithm for understanding a decision path. The next question. A telecommunication company wants to predict whether a customer is likely to leave the service. This is commonly referred to as customer churn. The available features are monthly bill, contract type, internet usage, customer support call, and payment history. The options are option A, decision tree, option B, K-means clustering, option C, artificial neural network, and option D, principal component analysis. The correct answer is decision tree because the problem is a prediction or a classification problem where historical examples can be used to learn whether the customer leave the service or remain in the company. A decision tree can learn patterns from these features and use them to classify a new customer. Next question is, which of the following is not a component of a decision tree? Root node, decision node, hidden layer, and leaf layer. As we have seen earlier, the answer is hidden layer. A decision tree contains root node, decision node, as well as a leaf node. Next, let us summarize what we have learned in this lecture. We started with predictive analytics. Predictive analytics uses historical data and analytics technique to estimate future outcomes. We then reviewed the machine learning. Machine learning allows computer to learn patterns from data. We discussed three major types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. We learned decision tree belongs to supervised learning. Then we defined a decision tree. A decision tree is supervised learning algorithm that represents a decision using a tree-like hierarchical structure. We studied its major components like root node, decision node, and branches. And we have seen various applications of decision tree. So thank you everyone. Feel free to contact me for any doubts. Thank you. Happy learning.